Hi, fourth graders. I was thinking about our math work so far this unit, and I was realizing we've been doing a lot of place value work. And this place value work that we're doing is so important to your learning as a fourth grader. Understanding place value is crucial to understanding these standards in this work that we're going to be doing this unit and throughout this fourth grade year. But today, I wanted to sort of take a different lens into how we're going to work in math today. Instead of me teaching you a concept and then you practicing it on your own, we're going to work together on using our place value knowledge and structure to solve a problem. We need to crack a code, and I need your help in order to do that. So when we're cracking a code, we're going to be working with our knowledge of place value. So I want you to think of everything you've learned so far on how to establish place value, understanding place value, and even how to answer a question in math in words. But before we really get into it, let's start with the warm-up. I want you to take a moment on a piece of paper on your whiteboard, and I want you to solve the next number that would come in each sequence. Pause the video, and when you're ready, press play. Okay, so we have three problems here that we need to work on. Our first sequence here, 3, 6, 9, 12, blank, 18. I think we all gathered this is skip counting by threes. So if it's skip counting by threes, I know my next space here, this missing spot, has to be 15 because 12 plus 3 equals 15. 15 plus 3 equals 18. So this correct answer would be 15. My second problem here, skip counted by larger numbers. 1, 5, 25, blank. So I know that 1 times 5 is 5. And then I know 5 times 5 is 25. So my next spot here to find this part of my sequence would be 25 times 5. And when you do 25 times 5, you get 125. My last one looked like it was skip counting by tens and multiplying by 10. 1 times 10 is 10. 10 times 10 is 100. 100 times 10 would give me 1,000. All right, so we're going to work on cracking the Muffin code today. You're going to be investigators in solving this problem, but we're going to be answering an open response question. When mathematicians answer open response questions, we use our understanding of place value, which is a mathematical structure, to decipher codes and figure out these codes. When you use this mathematical structure, you often look for patterns that help you make sense of the problem. Just like you look for patterns in those sequences in your warm-up, you need to look for patterns in your work today. It's going to be a super, super important day to make sure that you're showing your work. Let's get started. So to start off together, we're going to work through one type of code we need to decipher, and then you're going to go off and try to decipher another code. We're going to decipher Barbara's Bagel Bakery's problem. Let me read to you. At Barbara's Bagel Bakery, Bob packs bagels into boxes that hold 25 bagels, 5 bagels, or 1 bagel. We can see here we have a box of 25 bagels, a box of 5 bagels, and a box of 1 bagel. Bagels come to Bob on a tray, and Bob always fills the largest box possible and then makes sure to fill each box till it's full. For each tray of bagels, we need to find out how many boxes of each size Bob needs to fill. So before we get into this actual work, I really want you to picture this in your head. Bob works at a bakery. His bagels come to him in trays. They need to be in boxes when he gets an order of boxes of 25, boxes of 5, and boxes of 1. He wants to fill the largest boxes first, and then he'll move on to the smaller boxes. So we need to help him with his orders. Keeping your information of these boxes in mind, we need to think, okay, how would Bob box these bagels? The first one says, okay, the first amount of bagels he has on the tray is 27. So I need to think, okay, if Bob has 27 bagels and he wants to fill the largest box first, he could put them in boxes of 25 bagels, boxes of 5 bagels, or boxes of 1 bagel. I know that 25 is 2 away from 27. So he can definitely get 1 box of 25. Now he has 2 bagels left to get to 27. Boxes of 5 bagels, well, I know that Bob only has 2 bagels left in this order. So he wouldn't use a box of 5 bagels because he'd have 3 open spaces. So I'm going to write 0. Boxes of 1 bagel, I know he has 2 bagels left. So he's going to use 2 boxes of 1 to fill this order. So to recap, for a tray of 27 bagels, Bob uses 1 box of 25, 0 boxes of 5, and 2 boxes of 1. Let's try the next one. He has 10 bagels on this tray. Well, I know he wouldn't use a box of 25 bagels because he only has 10. So I'm going to put a 0 there. Boxes of 5 bagels. Well, 10 is a multiple of 5, so I could probably think about how many groups of 5 I could make to get to 10. 5, 10. I could use 2. 2 boxes with 5 bagels each. That gets me 10. So when it comes to boxes of 1, he'd have 0. Mathematicians, I want you to take a minute now, and I want you to pause the video. And when you do, your job is to solve, well, how many boxes is Bob going to use for 53 bagels? And how many boxes is Bob going to use for 9 bagels? It's okay if you don't know the answer, but you have to try and give it your best effort. So pause the video, and when you're ready, press play. All right, mathematicians, so let's take a look to how we're helping Bob out here. So if he has 53 bagels on a tray, we know that 25 and 25 is 50. So we could use 2 boxes of 25 to help Bob fill this tray. After I do that, with my 2 boxes of 25, I know I have 3 bagels left over. So I don't use any boxes with 5 bagels, but I would use 3 boxes of 1. 2 groups of 25, 3 groups of 1 is going to get me 53. For my last grouping of 9, I need to think, well, do I need any boxes of 25 bagels for only 9? No. So I'm going to put 0 there. Boxes of 5 bagels. Well, I know that 5 is smaller than 9, so I definitely could use it. But if I only have 9, I wouldn't use 2 boxes of 5 because that's 10. I could use 1 box of 5. And then if I have 1 box of 5, I have 4 left over to get to 9. So I'd use 4 boxes of 1 bagel. Do you see how we use place value to answer these questions? This is the kind of work we're going to do today. It's tricky, but you're going to be able to do it. So I have a problem I need you to help me solve. We need to crack the muffin code. Marcus takes orders at the Marvelous Muffin Market. The muffins are packed into boxes that hold 27, 9, 3, or 1 muffin, similar to Bob's and his bagels, just with different numbers. Marcus always fills the largest box first, uses the fewest number of boxes possible, and always sends boxes that are full. So he's not going to send a box of 5 when there's only 4. He's going to use individuals. When a customer asks for muffins, Marcus fills out an order form. This is his order form here. For an order of 5 muffins, Marcus writes a 1 and a 2. For an order of 19 muffins, Marcus writes a 2, a 0, and a 1. And for an order of 34 muffins, Marcus writes a 1, a 0, a 2, and a 1. Okay, so mathematicians, Your job today is to figure out what is this code that Marcus is using to fill out his orders for these muffins. You're going to need to show your work today. So I want you to remember, think about codes as number of boxes, not as base 10. It's not always going to be as simple as it seems. To help you visualize, I want you to picture that your job is to pack these muffins, just like we thought about Bob actually packing these boxes with his bagels. What kind of boxes would you use for the orders that you have? And when explaining your thinking, I really want you to think, first I packed a box with blank muffins. I had blank left. Next I packed a box with blank muffins, and so on and so on. It's so important that you show your work today so that we can really understand how place value plays a role in these orders. So let's get started, fourth graders. I'm really excited to see how you're going to crack this muffin code.